Welcome, welcome. Yeah, well, I mean, first things first, this last sprint, I think there was a good number of people that were out the first week, and then we were all in East Denver the second week. So this will be a relatively short demo day, but we did do a lot of stuff while we were at East Denver, so that's kind of cool too. Yeah, Javi, I know you want to go first. You want to jump on or screen share?
Yeah. Okay, so first of all, well, hi everyone, it's Javi. Okay, so first of all, I wanted to, I'm going to, share the wrong screen. This one. Okay, so mainly, as Ray said, my focus on this sprint has been on actually bootstrapping a feature that at the surface seemed pretty simple, which is to add this metadata option towards our models. But in the end, it has unraveled a lot of unexpected issues and troubleshooting, and it has taught us a lot of things amongst how about how Trino actually works, its limits, and some things that are definitely useful in the future. So the issue itself was pretty simple. We have this metric to 0 that did have actually before here this to do, and the display name was the same name. So it was a pretty simple task. We need to pass from the factory this metadata object on to also it's downstream, and here we can add a display name as a description. But it is not as simple as it seems, because here in the factory, how it works basically for anyone who will try to do this in the future is we have this this function which is called the generate models, which is where all the magic happens. And we have these macro overriding models, which is basically a function that when called, it passes this configuration and it gives us a macro handle. And here with SQL Glot, we actually write the SQL that will be run by Trino. The thing is that this SQL is super limited in some features. For example, Trino has a lot of limits regarding how large the query can be. So if we plan on generating a lot of inserts, this won't work. It also has a lot of restraints regarding complexity. There's this thing which is called a step, which is just a unit in which Trino tells us how complex one query is. For example, if I'm doing a select, I'm aggregating, and then I'm doing a lot of these things, each time Trino has to check something, it will count as one unit. The arbitrary limit for these units is 150, and if your query is more complex because it does a lot of the things, or it queries a lot of views, Trino will complain a lot, and there's not a really simple way to actually fix this. So how does this metadata thingy work? So first of all, for every metric query, that is for each of these small chunks that are stars, commits, and everything that will actually be generated, what it does is it creates an intermediate model, which is called metrics metadata underscore and the key, that will have this data, which is basically the display name, the description, and the metric itself, and it will just generate a select. This literally will do something like select, I don't know, stars as display name, description as description, blah, blah, blah. And everything, and this will basically bootstrap all intermediate tables, which will then be joined in the second one. So once we have all of these models, this small subsequence, we call this aggregate metadata that basically aggregates all metadata into this metrics metadata. But it is not as simple as it seems, because as if you can see here, this locals function is how we pass everything, all the variables between our land and SQL Mesh land. And SQL Mesh land is super restricted because what it does is it takes a snapshot and it copies all variables and everything. But you need to pass things like JSON or you cannot pass things that are hard to serialize because it won't work. So what I was doing at the beginning is just passing a list of all tables that needed to be joined. The thing is that this is too much for SQL Mesh and it complained, which means that we need to find another workaround. So the workaround that I found actually is this underscore snapshots variable, which is super useful, that is actually hidden. And basically what it does is it's basically a dictionary of all render tables with some metadata. So what I do here is I basically filter all of the tables that start with metrics metadata, which is basically our intermediate models, and then I aggregate all of them. The thing is this make select works because there are only 27 of these actually, of these small chunks, but if we do it with all the render queries, we get 500 of them, 600. So this means that Trino won't be able to handle it because it's too much and it will fail. So that's why we needed to add with this. So basically what we have now is this intermediate table, which has basically just the metadata, and this table that basically has all the unions of all selects. but this doesn't have the correct ID because it doesn't have like the GitHub releases over 180 days. It just has like GitHub releases. So what I'm doing in the metrics v0 is I'm using a light to see if there's like the metric in the middle, and then there's like a prefix, for example, GitHub, and a suffix like over 180 days, like over a project, and that's how basically this works. So some cool things that people should know is that if they want to add and generate something in the factory, they have to do it in this generate models factory. The SQL mesh, the SQL that they have to write, the SQL glot, needs to be relatively simple because it grows exponentially super quick and it is hard to debug, and it will work locally but will fail in production. So that's something to keep in mind. Yeah, in the end, using this like approach actually works, and that is basically how I got everything to work. We tried a lot of different things, like passing everything manually, trying to lazy load it, increase tree no limit for stages. And in the end, this was a slow approach, but in the end, we got it to work. So yeah, I'm proud of finishing this. And this gives basically everyone a good knowledge of how to actually generate SQL mesh queries without having to like, go through all of the pipeline and see how everything works. All the magic works there.
Cool.
Any questions?
I have one quick question, which is like, if we were to update this in the future, I feel like we spent a while debugging this. Like you spent a while debugging this, not me. If we were to like, this won't be the last time that we make a change. And so I'm curious if you have any like best practices for, given what you went through, how to either like, more clearly avoid that kind of debugging, or how to structure things in the future.
Yes, I do have some tips. So first of all, the way that we pass variables in between SQL Mesh and Dagsterland or what everything is, this is super fragile, which means that you cannot pass big objects here, you cannot pass classes here, you cannot pass anything that is not a simple dict or a string. So we need to like avoid relying on this. That is why, for example, here on locals, we don't have everything. So we consume it like this. So for example, we say the metric itself is this string, getting like from the evaluator, and the method itself. So my approach was to actually pass the list of all models that needed to be unioned, but that is not the way to go because that is super fragile and it will cause a query so big that SQL Mesh won't be able to, well, it will be able to run it, but Trino will fail. So try to lazy load everything, compute it yourself on SQL Mesh land instead of passing them in between because it is not efficient. Then be really aware when you set this kind. I had it set it to view by mistake, and I actually spent some time debugging this. So please, if you're going to do a lot of aggregations, make this full. And yeah, you need to also add the columns. And and okay, so if you want to use here this evaluator macro, like underscore snapshots, you need to pass this depends on list, which is basically a list of the models that it depends on, which is, for example, metrics, metric metadata, I don't know, stars over 180 days, stars over 60 days. So for that to work, you need to populate this one. And I think that's it. Yeah, be careful of the queries that you do.
The other thing that you and I also talked about, Javi, was around the basically like if you do want to pass things into the model via the variables, you would want to do only very small objects, right? And so to be able to get the metrics metadata to work, maybe at an earlier stage, we could have passed it in at a much earlier stage. That being said, that would have caused the entire recompute of all metrics because we would have to update everything, which is why we avoided that this time around. I might just throw that in as part of once I get all the events and blockchain stuff because we have to recompute metrics anyway. That would in theory that should be not a very large add to the Parquet files. They should be able to handle, like, it's low cardinality, so it should be very, very compressed. And then the only thing is it would add columns, but I think it's compressible enough that it should only be essentially the size of the data in those as a single string. And then yeah, like very, very, very small after that. But yeah, we, if we did it that way, you'd be able to perform all of this, and not have to worry about it. I think one of the things is we were trying to do a lot of processing of a bunch of things that had already been generated at a later stage, and that caused us either to jam something in at a later stage, or generate a bunch of tables like we have here. So yeah, and when we jam something in, we found out that SQL Mesh can't handle that for whatever reason.
Yeah.
So.
We have an issue tracking what Ruben said earlier. So it is there, we're tracking it. We have like some action. So I think that is something that we wanted to do before we rename everything as well. So before like the refresh, we need to rename everything, add this, and yeah, we need to add more things.
I think the moral of the story is the more denormalized that we can keep tables, the better. Like until we get to the marks. So yeah, fully normalized tables just they make more joins, they make more other processing. So yeah, for these kinds of things like adding that the metadata name, the metadata data and or the metadata display name and other like descriptions and stuff like that. Having that denormalized actually does help with processing. So yep.
Thank you.
But
Cool.
otherwise,
Thanks.
actually done. I know you worked really hard to get this past week. So
Yeah,
great.
thanks. I know it was painful, so thank you for getting it together. It seemed like a simple ask, and it turned out to be not.
Well, we learned a lot. I mean, we learned about like tune
We
stages.
did
We
learn a
know
lot.
how it failed. So now we actually know what even better how to debug this, how to like see all the planner and everything. So I think it was pretty useful.
And Javi, I know you raised an issue around kind of grouping of metrics or some kind of way of
Yes.
helping you identify anything that is related to stars or anything that's GitHub related, et cetera. Does that fit in at all here?
Yes. So yes. So how I was thinking about doing it is, so we know that we have like here in Metric Factory, we have like this key. So I was thinking of like adding that as a separate like group, which is like a group ID, which would have made everything way easier because like the biggest pain point here is the fact that this metric ID, this like the metric ID from here is actually generated here, and it is by doing the concat of the event source underscore and column.
Right.
Which is hard to compute in an undeterministic way. If this would have been just the column or just the event source, this would have been pretty trivial. In the end, it's just a join, But we had to do some hoops. So if we end up adding the new column, which is something I'm tracking as well on another issue, it would have been a simple join at the end. So yes, this will help the front end be able to like actually show related metrics in the same place, and it will actually help us to do like more joins with more, control over what we do without having to like calculate everything a bunch of times.
Yeah, I mean, I think again, this speaks to, as much as possible, let's just keep things denormalized and then, like join them or concat them or whatever, like reduce them in a later stage.
Yep.
Cool. Yes. Should we skip to Javi and Pyoso?
Yeah, so actually Ikro asked if I could show something because I had something teed up.
Okay.
Just checking, Ikro, if that's still okay with you, right?
Yes.
Excellent. All right. No problem, because I have been playing around with Pyoso. I'm very excited about it. I have a few things to share here. Let me just start. Okay, so we'll begin. This is the Insights repo. This is where we do most of our data science work. I've now created a quick start, which shows people how to use Pyoso. It's very simple. All you need to do is get your API key, which you can get for free from the OSO website. And then you can come in and just drop in pure SQL. You can run it, and you get a result back in a data frame. So hopefully quite intuitive. And now actually I'm going to show another example of how I use that. But I guess first off, if you haven't tried Pyoso, I'm talking about you specifically, Rohit, and then Mohammed, if this is something you're interested in, give it a shot. You can pip install it, or you can get it however you like. And it's a great way to go directly to the production data sets and hopefully get everything you need. If there's stuff that's missing, open an issue and we'll get it in there.
Yeah, it's relatively new as of like a couple weeks ago. I'm curious, Carl, in the amount of time that you've played with this so far, any gotchas, anything breaks?
Nothing. There's some like syntax stuff, just getting used to ClickHouse SQL versus BigQuery SQL. I don't think there's any real gotchas at this point. All the gotchas are on the data side, not on the interface side. There are a lot of gotchas on the data side, but we're working to clean all that up. So let me actually share an example of that. So this is something I did this morning just to get a sense of how much coverage we have between the data that's coming in from OP Atlas and what we already have in OSS directory. So the goal here was to, number one, test that the integration is working. We are getting projects and artifacts coming from OP Atlas as our second source. The next goal was to do a quick high-level check to see if we're getting metrics. And then the final step is actually to sanity check the metrics that we're getting computed on our side with what you might get if you were to query the raw blockchain data directly. So I'll quickly walk you through that. Again, the main thing I want to highlight here is that I'm using PyOSO for all of these queries, as opposed to a more complicated way of trying to join different data sets between BigQuery and, I don't know, something else. So again, same process. You want to pip install PyOSO if you don't have it, drop in your API key, and then you can come right in and connect. Actually, I can just run this directly. Let me do that instead. OK, so I'm going to refresh this. This is my notebook. It's going. I've kind of looked up a project ID already. You could obviously find your own, but I'm going to use Velodrome as my example. And so here we are. We're going to query the projects table and look up a project ID, which is coming from the OP Atlas data set. So hopefully that will still work. Yep, there it is. It's very fast. We get the information back. The next thing we can do, and here's a gotcha, is see what artifacts we have associated with this project. Now, this is not going to return anything because we're literally wiring this up right now. This is one of the bigger tables, so it does take a bit longer to give a result. I think that was like, I don't know, a second, 2 seconds. We don't get anything here. If we look for metrics, we're also not going to get anything. And by the way, I'm just copying the project ID from here and dropping it in over here.
Nice.
But in any case, if you've done BigQuery style queries, this is very similar. In general, you can pass variables in like this, and yeah, like you can get the results either as JSON or you can convert it to a data frame by doing something like that. So hopefully nothing crazy here. Next, trying to get a sense of how much coverage we have with our metrics. So again, we don't have an OP Atlas ID to work with, so I'm going to use the OSO project ID for Velodrome. So we run that. Here we go. This is the project ID that I will use. I'm going to copy that in here and drop this in. And what we're looking for is any metric that is available for this date in the time series metrics by project table. So we run this. Again, very fast. Love it. This is obviously not everything that we have. It's a subset of things. We can figure out why that might be the case. But here are some of the metrics that we have right now. You can see the name, the date, and then the value over here. This is kind of getting at the question that I asked Javi around like grouping metrics, because right now, the only way to do it is to like semantically look for active addresses, and that will give you active addresses on optimism and mode in this case. If you're on 20 different chains, then you need to, I guess, specify which chains you want and aggregate all those things together. Not a big deal at this point, but probably in the future, something we'll want to think through. In any case, just to get a sense of these are the metrics that Optimism wants and how much coverage we have right now. So we have active addresses for 2 chains across 30, 90, and 100-day windows. Same for transactions, gas fees. We don't have TVL. We're wiring that up right now. So we have 3 out of the 4 metrics that we need already. And now we can just do a query to see what it looks like, what the data looks like. And I'm just going to run this. I'm just dropping into Plotly so you can get a sense of what the graph will look like. And you can kind of see that, I think this is because we're using old data. It's not fresh. It's not hooked up to the superchain data set. As you go farther out, it's pulling fewer and fewer. I think we probably stopped this around mid-January or something. So as you get towards the end here, you're not really getting any new events. And that's why this number is going down.
Yeah, I think I filed an issue for this a while ago, Ruben, of like, if we have a rolling window, like stop it at, stop it at the right edge instead of the left edge.
We can. I guess the only issue is that, like, I mean, ideally the data would be up to date, but I guess like the pipeline, right now is stopped. So we're not operating in an ideal circumstance. So I guess the problem is like SQL Mesh isn't smart enough to know that the data is not there.
Oh, there's no end date in SQL Mesh.
There, you can specify an end date, but it believes that end date is today when you run it in production.
No, but can you specify an explicit end date? Because like this will always be an issue. Imagine you have a 90-day rolling window, right?
Yeah. But the thing is like, do we assume that we're always missing the last month or something like that? Like, we would have to assume that we're missing some X.
Sorry. I know that I've asked this like a million times. Imagine it's 90 days, so it's literally 3 months, right?
Yeah.
Does it stop at the right side of the window or the left side of the window?
It starts at the right side of the window. Wait. Yes, right side of the window.
Okay. So I see. So you're saying this will be fixed as long as we are running it regularly.
Yes. So assume that, oh, you're not seeing my mouse. So where things start dipping around February 2nd, let's assume that that's where the data stops, right? Like right around here.
Yeah.
Assuming that it is also February 2nd, then that it would just look like that. Yeah. Right. Like, oh, okay, we have data, yeah. As opposed to right now, it has this like tail, this falling tail, which, yeah, if we had updated data constantly, it should not have that.
Okay.
Mm-hmm.
Okay, cool.
Sorry for asking you the same question for the 20th time. I'm sure.
No, it's fine. Yeah, I'm like, I just don't want to solve it. It's fine.
Yeah.
Yeah, it's interesting actually, because I think it depends a little bit on when this ran, or maybe it's the same actually. Yeah, okay. I'm not quite sure, but hopefully the end date is the same for all of these.
Mm-hmm.
But anyway, we can test those kind of things here. And then here's the last one. So we have gas fees. Just a quick sanity check. Actually, I don't know if you guys have seen this, but Grow the Pie is using our data, and they have their own metrics.
Oh.
So we can always check our results against theirs.
Oh, okay.
But they have, more than we do. There's two reasons for this right now. Reason number one is that Velodrome is one of the projects that is failing right now in the build. There are new addresses that have been added in a recent PR, and I think Grow the Pie is using that. We are not. And so, yeah, that is why, that is part of the issue here, is that there's just some new contracts that we haven't brought through yet. And we can also standardly check what we have. Again, this is just looking at what we have in OSS directory. It's not the exact same thing as, this is what has been synced from OSS directory. What's actually in OSS directory, the GitHub repo is a bit more. But we can do a quick sanity check on the numbers that we have here. So just keep this number in mind. Let's see, about 1,000 or so addresses in January. Then we can come in here and actually query these numbers. I won't run it now just because it's expensive to scan this data set.
Mm-hmm.
But I'm going to come in and just see what we get back by looking at the raw on-chain data here for everything that is Velodrome related. And you definitely get more. You get about 9,000 active addresses.
Mm-hmm.
So I think that's partly because we were it's a bit outdated and we didn't have all the contracts in there. But anyway, so there's some issues with the data, but it's cool that PyOSO allows us to explore this stuff very quickly. And I will say this is like, 20 minutes this morning to pull together. Super easy. The queries are very, very fast. And so, from a user experience as an analyst, it's very satisfying.
Yeah, it's the
Sweet.
main benefit is like the queries run significantly faster than BigQuery, right?
Yeah, 100%.
Sweet.
And
Yeah, I can't
obviously.
wait to make you rewrite all of these in Trino SQL instead of ClickHouse SQL.
All right.
Oh, sorry.
Yeah, so that's that. Let me switch gears now. So the other thing, so this is all kind of the theory right now. Where this is showing up in practice is that right now we have created two different algorithms, and they are up for voting right now. This is the retrofunding snapshot page, and I actually haven't looked at this in a couple of days, but we've cleared quorum. There's actually 58 votes. A lot of people voted. There's pretty lively discussion happening, mostly from me, but people are asking questions. So you can see all that here. There's like some technical questions that are coming in, etc. But yeah, it looks like algorithm number 1 is the most popular so far. We can see the details on how that works. Let's see. So I'm going to go in and click on one of the Hex dashboards that we have. If you've seen this before, apologies. But basically, what we showed was a simulation. So this is actually not the products that have applied, because as you saw a minute ago, we are still doing some data quality checks on the products that have applied. So this is purely a simulation based on projects that applied in previous retro funding rounds, what it would look like if they were to appear again. The other thing to know about the dev tooling one is that the way that all of the metrics are being expressed is as some kind of function of so you have the dev tooling projects over here, and we've built this graph. And so the importance of a dev tooling project is a function of which on-chain products are using it. And there's different ways an on-chain project can interact with a dev tooling project. They can import one of its dependencies or one of its packages and be a dependency, or be a dependent of one of the project's dependencies. They can also have developers that are contributing to it or engaging in other ways like starring, forking, etc. So there's a number of ways that you can kind of establish this link between an on-chain project and a dev tooling project. All of this is effectively expressed in this big graph that we have over here. So if you want to go in and literally get the data out, this is it. There's 23,000 links in it. But what we've done is create we've established these links, and then we have 3 different algorithms for weighting the importance of different links. And you can see here, the one that is most popular right now really just looks at the most widely adopted projects. It doesn't do anything that fancy. It prioritizes the total dependence and the economic weight of those dependents. So basically, if you are a package which is used by Uniswap or Velodrome or one of these other big projects, you should do well in this with this algorithm. And we can show some of the details here. So this is Arcturus. This is the one that is being simulated. Again, using the dynamics of the round in terms of what the budget is and the caps on both the top and the end, you can see what a simulated set of rewards would be. 5 of the top projects, again, this is a simulation that would come out, are these ones here. So Ethers, Open Zeppelin, Webm, Hardhat, etc. And you can see what the distribution looks like. We're also doing some data bounties. So if people want to come in and create a better metric or a better algorithm, they can take some of this raw data, and then we have a repo here that Optimism has set up where people can come in and look specifically at the algos. Let's say that you want to change the weights on the Arcturus model. You could come in here and play around with all these settings. And then following these instructions, you should be able to poetry install and then run an algorithm. And if you give it a new YAML file, you can just pass that as one of the arguments here. And then you can get the results, but you're using kind of simulated data. So we have the raw data over here. These are the tables that we're working on creating in the real world right now in SQL Mesh, but that has everything you need. Show an example. Yeah, so that's all the raw data. And those are the main things. We can just go back here. If we look at this, we also have the on-chain builders one. Ooh, this one's actually gotten close. Wow, there's been some drama recently. Superscale was ahead. It looks like the Goldilocks algorithm is pulling ahead now. Interesting. That'll close out in 2 more days. But yeah, so far there's been pretty good discussion, but nothing stopped the press. We need to rethink this, which is a big relief for me because I was definitely losing sleep over this. Let me see. The last thing that I'm excited to share is.
Can I ask a quick question, just since you're on this page already?
Yeah.
Like, I haven't been monitoring the chatter as much, and I know that in the beginning there were some concerns about like doing things in a metric-oriented way or whatever. I'm curious, like, yeah, this is super cool to see it live. I'm curious, given that you've been doing more of the community engagement thus far and answering questions, what's the general impression that you have so far of like this approach compared to past rounds? It's quite different, right?
Yeah, it's very different. I think it's probably a bit too early to say overall how people are going to feel about it. I think right now we've tried to underscore the fact that this is really going to be an iterative process and the algorithms will evolve each month based on feedback. The main feedback that we've had right now, number one, has been coming up with better user models. So actually, let me come over here and I can share some of the issues that are coming in. So a lot of people have commented about going beyond just using forecaster IDs. An issue. Some people have come in and given some suggestions for what could be done here. And yeah, Jonas has curated some of the feedback. We like that. So hopefully there'll be some work on building out better user models. I think the other thing which has come up is kind of a known issue, but how we link more to the on-chain supply chain. So one good example of this, and Ruben, maybe you'll enjoy this, is that you have these Create 2 factories, which many developers use so they can manage their deployments and have them all have the same address across chains. Is that an on-chain builder or a dev tooling project? I think people would say it's probably more of a dev tool. And so anyone who uses that factory should potentially be able to give some dev tooling credit to the maker of the Create factory, Create X in this case. So something we need to consider, we have the data to do this. I think the recommendation would be to create like another link in the same way that we have package links. The next set of issues are really just, obvious stuff related to how do we tell, just because something is popular doesn't mean it's important. How can we get a better sense of what's actually important here? And yeah, some people thinking that projects should be lower down that are, very popular but not very useful, and so on. So I think that will be there'll be a steady amount of feedback related to just the overall ranking where projects sit.
This is like the ideal of all worlds, right? Which is that, like, yes, we get that the metrics are naive right now, but people are excited to engage in the evolution of how these metrics evolve into the future versus like, like how do you channel their engagement energy, right? Are you finding that like this is resonating as like the way to engage with the process?
The next step is there's some budget for the number nerds to actually start responding to some of these issues. So we're basically going to take some of these issues that have appeared and actually put them up on the number nerds board and get some people there to contribute.
All the number nerds.
Yeah. Yep. Okay. So this is the feedback from Vectorized. Exactly. Yeah, there's obviously a lot of surface area here. There are many things to explore. I I think what would make me most happy is if we had a few people jump in and create a better metric model and tweak some of the algorithms and improve it there. It's less useful for people just to kind of come in and complain about things, but not actually do anything about it. Like as an example, I capture all these things here. I'd love it if someone actually did this, right? Create a public data set for Gnosis Pay. I don't think that we need to be necessarily ourselves doing each one of these. Ideally, straightforward for someone else to kind of curate that data set, and we can help connect it, but I don't want to be doing the heavy lifting of actually tracking down the data and cleaning it and so on. This is another one that I know that Chushin has wanted to work on, is being able to build up a registry of the central exchange addresses and then identifying, which central exchange did you come from.
Cool. Exciting.
And then the last thing I will share is, all right, who can spot what's new here? This is a trivia.
New as when?
Oh,
437.
437. No, nice.
We've got it. Yes.
Yes.
So we can come in here. It's in, let me just share that specific query. You want to see, let's just make sure it still works. Not too big because we haven't done the historic backfill. But there we are. These are the most popular paymasters. And there's Base's native paymaster coming in at number 1. World Chain's big, etc. You can go down the list. Cool to see. Like Sonium has actually had a lot of activity. I think there's a lot of account abstraction happening there as well. But yeah, you can go down and see everything. So finally, never too late.
Awesome.
And this was was this produced by Pedro running the a limited decoder against all traces and then producing this data set basically?
Yep, exactly.
Okay. And I think, is it fair to say that OP Labs will never produce a comprehensive decoded traces data set? Or is that, I don't know, just curious.
I mean, I don't think I couldn't see them doing that anytime soon, just given that you probably, even Dune, which has been doing that for years, they don't have everything. They have, I don't know, just the contracts that have been submitted for decoding, which is probably, I don't know, 50% or something, but there's a lot that hasn't been decoded.
Yeah, makes sense. I'm just curious, what their strategy is. Because, I mean, this is not the last thing that we're going to want to decode. So we're going to have a separate data set for every contract interface or something.
Yeah, I don't know. We should discuss that on Thursday with them. So yeah, I think that's all I have for demo. Any other questions?
Just one comment. I think, yeah. Chushin was saying we should come in on Thursday. I would love to talk in general with their team about splitting up the superchain data by chain. Yes. So yeah, because otherwise I really do think that those superchain data sets on BigQuery become unusable for people. So to the extent that we may do this with this superchain 4337 stuff, that would be cool as well.
Yeah, totally.
I don't know if this is going to be constantly updated. So, but yeah.
Yep, makes sense.
Yeah. I think I forget who requested it, but there was a request to join all of them from I
believe it was Michael. Yeah.
I don't know. That's not important, but it's just I think there's conflicting desires here from a data engineer versus a data scientist perspective.
Oh yeah, I mean, I think you could still join it. You just
right.
Yeah,
It's just when we process it, we want it partitioned, right?
Yeah. Well, yeah. When anyone who isn't, anyone who has a small budget will want it split. Yeah.
Well, I think, what it sounded like Chushin was saying is that everything is just Parquet files, so we can use that, right?
Yeah, exactly. If it's all Parquet files and they're split by chain, like that would be ideal. Or at least, date. Then it's kind of up to us, right? But yeah, which is fine. That's also fine. Cool. Cool.
Sweet. Nice to see you, Meg. Have you voted yet for the snapshot?
No, that's on my list for sometime shortly before the deadline.
All right, you've got 48 hours.
I know. I checked my Discord notifications for once and was like, oh my God, OSO's having office hours right now and I'm free. So I just popped in here and hope that's okay.
Yeah, totally.
Yeah, of course.
Oh yeah, thanks for, this is the kind of stuff that like I have nothing to contribute to, but I'm fascinated by. So thanks for
Oh
letting me.
yeah, I mean, we just, we just like showing what we're doing to the public. Doesn't really, yeah, like random stuff here.
Well, you guys are on a roll. Don't let me cramp it.
I think we're nearing the end, actually. Do you want to?
Is it me next? Yeah. Cool. Yeah. So yeah, this is very random stuff for most people. But let's take a look really quick. I just wanted to go over something. So we were doing some cost-cutting measures on our side. So one of the things that we have is all this Gold Sky data, and we're just kind of cleaning up some of the Parquet files that we have in our GCS. I created a tool because if you were to do like trigger this delete folder here, it's very possible that the GCP UI will just straight up fail. So I started noticing that, and instead of actually relying on them, I created some functions for us. So this is just sort of a heads up, but we have this delete GCS util now in our metrics tools. Again, once we rename these, this will move around to like the core common or whatever we had talked about for the name of that library. But basically, this is an async function, and I use async because using the synchronous version will take years probably to delete everything. So yeah, I give a little bit of an example of how to use this. I just run this, by creating a script just like this. I didn't think we needed anything very specific here on like the command line, so I didn't do that. I just wanted to provide these functions. But the reason, again, that you want to do this is that if you're deleting many files on GCS, the front-end API that's available on the UI seems to time out. So this is a little bit more sturdy at that, but I'm still getting some strange timeout errors that I thought I was catching, but they're not catching at the right place. So I'll take a look at that, but for now, this is available.
Yeah, there's a lesson in here, which is like, for folks that weren't there in the meeting in Denver, there was a long section where we talked about how we're big fans of Google, we love Google, but they're really dropping the ball on GCP, and this is another example of that, which is like a reasonable guess would be that they don't actually use the user interface that everybody else uses, and so they're not catching these things because they don't use this internally. And then it's a question of whether or not their customers care enough to actually report it to them, which is like another good reminder that like, yeah, we should regularly be using all of the interfaces and all the libraries that we're like exporting. Like, I think it's awesome that Carl's starting to migrate more things to PyOSO, and we should just like stick to that, and we should just not allow, say, for example, direct, Trino access, right, to kind of bypass any bugs that might arise at the translation layer, because like this is the kind of stuff that happens when you end up neglecting using your own dog food.
Cool. Yeah, that's it.
One other thing I realized we didn't demo, but I think is super cool, is the contract v0 model. We didn't demo
Oh.
that the other week.
I guess we've never demoed that. Yeah, I don't think I was here for when the demo day landed for that anyhow, or would have landed for that. But yeah.
Well, I just updated our PyOSO quick start with a
Ooh.
contract v0 demo.
Very nice.
I'll run it now. This one takes a bit longer because it's a big file, right? Let's see.
Huge.
It's about 5 seconds, maybe. I
Mm.
can time it, but okay, this one's okay. There we go. But it's doing account distinct, so that's a pretty expensive operation. But yeah, you can see what we have here. So these are all the different chains, number of deployers, number of contracts. Ruben, this kind of gets at the issue around the originating address being important in some places.
Mm-hmm.
So in like world chain, for instance, I think we need to be using the originating address instead of the root address.
How would we want to build that in? Is that
I have some thoughts. Yeah, it's
yeah.
it's
I mean, I can always include that data in contract v0, so it's up to the caller of contract v0.
I think that's what we do. And then when it comes to our discovery model, I think we just need to differentiate between a crate and a crate 2.
Okay. I think actually all of those columns are already there. I just probably removed them from contract v0 to make it small. Yeah.
I think it's all there. But anyway, this is kind of cool to see.
Yeah.
And I don't think anybody else, I haven't seen any data set like this, actually. I think it's pretty unique.
Yeah, I mean, this is, it's our one thing that indexes the universe. It is quite cool.
All right, and we could obviously get like the start date, and we can see how frequently these things are going. But yeah, that's all I got. PyOSO.
Woo! PyOSO. All right.
Awesome. How long do you think that would have run on BigQuery?
Oh God.
Oh wow.
It would have been very expensive, I'll tell you that. I don't know how long it would have run, but I can tell you it would have cost us hundreds of dollars. Like at every stage, and I think there are like 7 or 8 stages or something like that. So yeah. Because this was at like 50 terabytes of data input, and then we do a bunch of transforms on that. So
yeah, it's big.
It's huge.
It's not getting smaller.
No.
All right. Well, thanks everyone for joining in. See you in 2 weeks.
Thanks.
Cool. Later, guys.